The paper investigates an intelligent reflecting surface (IRS-aided mmWave integrated sensing and communication (ISAC) system. It proposes an ISAC protocol for achieving simultaneous communication and sensing via beam training and sensing. The IRS finds the optimal beam for reflecting signals from the base station to a communication user and estimates the angle of a nearby target based on its echo signal. The protocol derives the achievable rate of the communication user and the Cramer-Rao bound, CRB, of the angle estimation for the sensing target in closed form. Simulation results show that the achievable rate initially rises and subsequently declines, while the CRB monotonically decreases. The STAS protocol outperforms the benchmark protocol with orthogonal beam training and sensing due to its efficient use of the downlink scanning signal for simultaneous sensing. The system model considers an ISAC system with a semi-passive IRS, where an antenna BS attempts to communicate with a single antenna user and detect the angle of a sensing target from the IRS. The direct links between the BS and the user, as well as the target, are assumed to be blocked due to unfavorable propagation environment. The proposed IRS-aided mmWave STAS protocol for ISAC systems combines downlink beam scanning with sensing, enhancing both communication and sensing capabilities. In this protocol, the BS sends downlink training signals, and the IRS-res sweep through the beams in a given codebook while the IRS-SEs collect the echo signals reflected from the target. The user finds the IRS's best beam and feeds its index back to the IRS controller, which then adopts the best beam for data transmission. The achievable rate of the user is derived, and it is shown that increasing the codebook size, the number of BS antennas, the number of IRS-res, and the number of IRS-SEs can improve sensing accuracy. The CRB for angle estimation is also derived and validated through simulation results, demonstrating the tightness of the derived CRB at high SNR. The performance of the proposed STAS protocol is compared with a benchmark protocol, OTAS, which utilizes two separate beam scanning periods for communication and sensing. The results show that STAS outperforms OTAS in terms of achievable rate and sensing accuracy. The research proposes a novel STAS protocol that leverages downlink IRS beam scanning for simultaneous training and sensing in IR-aided mmWave ISAC. It derives the achievable rate of the communication user and the CRB of the target angle estimation given the IRS beam scanning codebook. The study shows that the achievable rate and CRB behave differently with the time of IRS beam scanning, highlighting the need for proper choice to balance communication and sensing performance. Additionally, the STAS protocol outperforms the OTAS protocol, which utilizes dedicated sensing time. The appendix provides detailed proofs for theorems on maximum likelihood estimation and the Fisher information matrix. The references list various works on integrated sensing and communication, including papers on IR-aided wireless networks, radar sensing, and statistical signal processing.